All right, welcome everybody to week 4, Thursday of week 4 of Energy 241. And by now you should have your assignments for week 3, both the homework and the quiz done. And the week 4 quiz on methanol is now open. And I'm going to go over a little bit of homework because we seem to be struggling with that. I've helped a couple students with it, and I think figuring out word problems and how do I convert the information over from the text that I have into an equation in the easiest manner possible is very important. So we're going to take a look at that, and I want to take a look at week 3, and we'll see how to work the week 3 problem. And hopefully with that, you guys will have a little better understanding when you get ready to dig into the week 4 homework, which is obviously a little more complicated. And we may even jump into that a little bit just to kind of go over the trick of how do I set up the equation. But I think once we show you week 3, you'll get a little better understanding. There really is kind of an art to doing word problems. They are definitely a challenge, and the trick that I've learned, and I think anybody that gets successful with them learns, is how do I convert the words to an equation, and what information is important, what information is not. And what I like to recommend to people is read the problem first, take a look at the information that's given, highlight what you think is important or underline it or whatever. Pay attention to the units. Looking at the question right here, we're looking at 98% yield for an alkaline catalyst, concentration of 0.7% by weight. So maybe not anything information in that sentence yet. Calculate the amount of lye in pounds. So I know right off the bat my answer that I'm looking for is in pounds. That's some useful information to me because at least now I know what units I'm working with. And necessary to react with 100 gallons. There's a quantity that's useful of peanut oil. So I have a density conversion there, and it shows 0.910 grams per cubic centimeter as the density of peanut oil. Well, that's great. Can I convert grams to pounds? And yes, I know that I can. And because my answer needs to be in pounds, I want to get to that unit as quickly as I can. Ideally, if I'm using similar units all the way through, it makes things a lot easier. So I've started out a little bit on here and said, okay, we have 100 gallons of peanut oil, and then it's 0.910 grams per cubic centimeter. I'd like to get that into pounds as soon as possible. I also know that at some point I need 0.07%. Actually, that's not right. I need 0.7% catalyst by weight to mix in with that 100 gallons of peanut oil to figure out what my final what that final number is going to be. So let me correct this right here so we're not screwing that part up. So what I need to do is basically get this into an equation, and I need to get 100 gallons of peanut oil by weight. I need to use my conversion. I've got my quantity here. I've got my weight here. And I need to figure out how I'm going to combine those so I can actually get them to be the same units as my final answer. So to start off with my equation, it's actually really straightforward. I have my 100 gallons, and I know what my weight is, 0.910 grams per cubic centimeter. Now is where my conversion comes in. I need to take a look at this and say, okay, how can I do this conversion to get gallons into pounds? And it's actually fairly easy to look up in Google. You're going to need some sort of a reference to tell you what this number is, but having already done that, I know that 3,785.4 cubic centimeters per gallon. So that gets us, now I can get, the gallon part is easy. I'm not so worried about the gallon part, but now I need to figure out how am I going to get those grams into pounds. Well, again, use Google, take a look at that, and I know that 1 pound is 454.5 grams. And what I'm looking at in this whole equation and the way I set it up, I can take either one of these numbers here, because this is basically, if you remember back to your basic algebra, this is 1 over 1. 1 divided by 1 equals 1. So 1 pound on top, 454.5 grams on the bottom. And I need to take a look at my units here. And I know, looking all the way back over here, my grams are on the top. So in that case, I want my grams on the bottom so I can cancel those out, because we're going for pounds. So I'm going to get rid of my grams. Those guys cancel out with each other. My cubic centimeters, I got it on top here. I got it on the bottom here. So those cancel out. And my only unit left that I have is pounds. So now it becomes a simple math problem, and when you punch that into your calculator, you're going to come out that that is 757.9 pounds of peanut oil. And now your math equation just got even easier, because your answer to that last problem was 757.9 pounds of peanut oil. And I know that my catalyst that I need to add to it is 0.007 pounds of catalyst. So I can just multiply that out, 0.007 of catalyst, and I get my answer. Pounds is my only unit in this, so I want my answer to be in pounds, which is what was asked for. And it turns out that it's 5.3 pounds of NaOH for your answer. I saw a lot of different attempts of people to do it different ways. Like I said, I think probably the easiest for you is figure out what unit your answer is in. Try to reach those units first. If you guys haven't already figured it out by week 4, and this is obviously 3rd or 4th semester class for you, a good conversion calculator, it's as simple as typing it into Google will get you the answer that you need. But find one that you like and that you're comfortable with, that you use all the time, because that's going to be a lifesaver when you're sitting here doing these problems. And we'll take a look at the one that I was just using. Sorry, the computer's locking up a little bit on me here. But literally I just punched in how many cubic centimeters are in a gallon, and that's where I came up with that conversion. And then I said, okay, how many grams are in a pound? And came up with that conversion. So it's actually very easy to, the answer pops right up. If you want to get tricky with it, you can actually put in, how many cubic centimeters are there in 100 gallons, and then you still have two conversions, because you still got to get it into pounds. You got to get your grams into pounds. But there are a lot of different ways to do it. Probably the hardest part of it is, though, in reading your question and getting rid of the extra information that you don't need. Figure out what units you need, figure out what numbers are valuable, and drop everything else. Then it's a simple matter of doing the equation. I'm going to pause this for a minute, see if I can't get rid of the screen that's locking up my computer. Well, I guess you guys will get to see me troubleshoot, because I got to try and shut it down. Okay, here we go. Sorry about that delay. So let's take a look at week 4 and look at that problem. And I'm not going to work it all the way through, obviously, because it's still due for you, but I'm going to help you pull out the information that's useful there, figure out how to set that up in an equation, and then I'll let you finish it up from there. And I think actually this one, for me at least, when I look at it, is even easier than the week 3 problem. You're given a lot of the information there that's already useful. So we're looking at methanol this week, obviously, but it is toxic, and we do have to worry about exposure for people to it. So we have some information given to us right off the bat. We have to kind of set a standard. What is a normal respiratory minute volume for a person? And it's going to be 15 liters per minute. So that's useful information we're definitely going to want to set aside for later, right? We can recognize that that's going to be useful. Person's exposed to it, we know what their exposure limit is, 260 milligrams per cubic meter for an entire 8-hour workday. So we have a time component in there. We have a quantity limit, and we also know their respiration rate. So right off the bat, we can put all that into an equation. And if you look, there's all our useful numbers. There's our occupational exposure limit. We know it's 15 liters per minute. We need to get our liters over to our cubic meters. We got to get those canceled out. So we have 1 cubic meter is over 1,000 liters. That's going to cancel those out for us. Our cubic meters will cancel out. We know there's 60 hours or 60 minutes in an hour, and there's 8 hours in a day. So all those multiples all together are hours cancel out, our minutes cancel out, and we're left with milligrams per day. So that's our allowable, or that's what that person would be exposed to for working an 8-hour day in those conditions. So 85% of that is actually inhaled, or that is inhaled is actually absorbed into the body, because we're not 100% efficient, right? Even when we're breathing out There's still oxygen in our breath. It's just at a reduced level. We pull some of it out. The rest of it we can't use, comes right back out. It's the same way with the methanol. Only about 85% of it is absorbed. So we need to figure out the time in hours, minutes, seconds. How long would it take a 70 kilogram person? Okay, that's going to be important because that'll tell us the absorption, right? To metabolize the absorbed methanol. Page 94 in the text has the rate of metabolism, so you need to take a look in your textbook and find that information. But let's take a look at what would the equation look like to get started on this problem. We're going to pick our important information out of there and draw that up into an equation. And like I said, we'll get you started on the whole process and let you work it from there. We'll go to a clean page, and this is the week 4 problem. And what's our useful information? That's what we're looking for out of there. We already know that max exposure limit was 1,872 milligrams per day. That was from our equation that was given in the problem. All right. Looking back at our word problem, see what's next on that. All right, we know that we're going to absorb 85% of that. So let's go back and figure out how we can use that information to our advantage. And that is literally as simple as 0.85 times this limit up here, 1872 milligrams. And if we were in that atmosphere, in that environment, and we only absorb 85% of it, we will have actually absorbed 1,591.2 milligrams. We'll just call that absorbed. Okay, so I want you to take a look. I'm going to give you a couple more little bits of information here, but I want you to look some of the information up. We know that our person weighs 70 kilograms. Big question mark right here for the metabolism rate, but you'll find that in your book. And it's going to give you a rate per hour of how much can it metabolize per hour. So once we figure that number out, you'll be able to determine how long it's going to take to get rid of this number that we've got up here. We know this is how much they absorbed. We know they weigh 70 kilograms, and we know what their metabolism rate is when we look that up. And it's a fairly simple math equation to give you your final answer. Now pay attention to what the question is asking. So you have all the details. We want to know the time in hours, minutes, and seconds. All right, so it's not just enough to say, well, you know, if they're in it for a day and then they sit out for a day, they're good and it's all cleared out. That's not the kind of answer we're looking for. We can get down very detailed. We know exactly what that rate is. So I want to know what the answer is in hours and minutes and seconds. And your math will tell you that easy enough. You're just going to have to add your equation. just like we did earlier for your conversions. Up here, we have 60 minutes per hour, we have 8 hours per day. Think in those units like that, and put those right into your equation, and that'll enable you to break this down right in your equation. So you're going to come up with an answer with decimal points and everything else. That will be your time that is the answer. So if you have any questions, definitely talk to Brad or I, swing by the office. I'll be more than happy to help you with it. But it should be pretty straightforward. I think we've given you enough here just by looking at this information. We've got half the math equation done right here. And this takes it down to a fairly easy level. Just like we did on last week's problem, once we got the weight of 100 pounds of peanut, or 100 gallons of peanut oil into pounds, the unit we wanted, you saw it was a very simple math equation. This is going to be exactly the same way. Now that you know this number up here of how many milligrams were actually absorbed, the math itself is very simple. It's just a matter of getting it into the right equation. So with that, please, like I said, swing by. If you have any questions, let us know, and we'll be more than happy to help you out.